Hello, welcome to Philosophy Roulette, number 85, I guess. So, where we read philosophy papers. I do take suggestions, otherwise I just grab whatever's available off the interwebs. So, let's take a look what's new. Consciousness and cognition. Barniver is discontinuous experimental design for the study of unconscious perceptual processing. Well, let's take a look. See what consciousness. See if I can figure out how long this is first. No, not at all. Okay. Oh, nothing of everything. There's no page numbers here. That's why. Okay, this is busted page numbers. So it's 102 to 904. What is this? I don't know what that means. Well, can't take enough of a chance. Studio Greater at Latina. What is this? So is this some sort of classicism? Classic. Alright, so we got Iranian or Kentness seems to be putting stuff out. And feminist legal studies, maybe. Ooh, Husserl studies. Interesting. Alright, so you do not have a table of contents? Am I clicking on the wrong thing? Alright, so this is just not available, Iran. So somehow that maybe was uploaded. Let's see. Well, it's available, but it's like 30 pages, so I'm not reading that because that would take 3 hours. Argentinists. Oh yeah, that's right. I looked at some of these earlier. Let's see what we got forthcoming from Argentinists. No, look at organization levels of organization in biology. 1 to 26 is too long. The reducibility of emotional phenomenology. Interesting, but we don't know the page count. So see if we can find out how long this is. Oh, no. 37 pages. No, thank you, even if you're double spaced. That's a little too much. That's too much. Disposition, causation, and the interaction gap. 16 pages. See if we can get some a little shorter. These are epistemology and the structure of language. 1 to 15, 1 to 14, causal emergence and epiphenomenal emergence. More emergentist stuff. Let's see what else we got. We did this takes more to answer existence questions the other day. That was fun. Indeterminism physics, 1 to 13. Ooh, 1 to 7 is the reality criterion analytic. I like that. I like 1 to 7. That makes me happy. Let's see if we are available. Woo, it's on archive.org. Who uploads philosophy to archive.org? Maybe, I don't know. Oh, let's see if this is really scientific then, maybe. Nah. This is not overly numerical. I can handle this. Okay, so this is what we'll be reading for at least now. So, if you are joining me live and you catch up midway, you can grab the link over here in the chat box. And here we go. That's good there. Now let's get the file loaded. Whoa. This one? Okay, here we go. Okay. I think that's it. Alright, good to go. So, no abstract, although I see Tim Maudlin, so we're in the philosophy of science then usually. Introduction. The reality criterion plays a central role in Einstein, Podolsky, and Rosen's argument against the completeness of quantum mechanics. That's the EPR stuff. EPR. Reality criterion RC. If, without in any way disturbing a system, we can predict with certainty, that is, with probability equal to unity, 1, probably 1, the value of a physical quantity, then there exists an element of reality corresponding to that quantity. Referencing Einstein, very cute. Okay. RC shares much of the intuitive appeal of scientific realism. On the basis of certain predictions, it licenses claims about objective reality, which may then be used to explain our successful predictive practices. But unlike scientific realism, RC only appeals to specific kinds of predictions made with certainty. It then allows us to infer the existence of something in reality corresponding to the predicted value of the quantity in question, for example, some property of the system under study. By focusing on predictions that can be made with certainty, which EPR identifies with probability 1 assignments. Yeah, see, this is interesting that they probability 1. Alright. RC represents a substantially weaker connection between our predictions and the world than full-blown scientific realism. RC requires ontological commitment to substantially less than the full content of quantum theory that traditional realism would seem to endorse. Yet, certain proposed interpretations of quantum mechanics must reject RC. Cubism, which originally stood for quantum Bayesianism, for instance, maintains that the probabilities delivered by quantum mechanics correspond to agents' subjective degrees of belief about their future experiences, for example, measurement of outcomes. Hence, there is the possibility on cubism to be perfectly certain about the outcome of some measurement, even assign it a probability equal to unity, without there being anything in reality that corresponds to the predicted outcome. Maudlin, however, claims that RC is not merely reasonable, as EPR find it, but analytically true. RC is, in the parlance of philosophers, analytic. That is, this criterion follows just from the very meanings of the words used in it. The difference is this: one can coherently, but not reasonably, deny a merely reasonable claim, but one can't coherently deny an analytic proposition. Analytic claims are true or false in virtue of meanings alone. To give the standard example, one can see that all bachelors are unmarried without any empirical knowledge. Its truth simply follows from what we mean by bachelor. If RC is analytically true, as Maudlin maintains, its denial is incoherent. To reject RC is to fail to grasp the meanings of the terms involved. Warner rightly points out that RC is a criterion, that is, a sufficient condition for identifying elements of reality, and that analyticity is something that traditionally applies to statements or judgments. However, consider the following conditional. For all men, if we ascertain that they are unmarried, then we may infer that they are bachelors. This conditional provides a criterion for checking whether grown men are indeed bachelors. Just investigate their marital status. But like the corresponding statement, the criterion itself might be called analytic, as denying its applicability would imply a want of understanding of the terms involved. Okay. Below, we will argue that RC is not analytic. However, there is a deeper worry that we suspect motivates Maudlin's claim, that cubism and views like it end up doing away with physical reality altogether. Cubism is one of a family of broadly epistemic approaches which regard quantum state as a reflection of an agent's knowledge, information, or beliefs. Other examples include Healy's pragmatist interpretation, Friedrich's therapeutic view, or Boge's neo-Kantian approach. These approaches reject RC as part of a more general rejection of the common representational role afforded to quantum mechanics, a theory which these approaches understand in the first instance is a guide for agents navigating the world. The worry is this: because of the many known restrictions to supplementing further variables to it, the abandonment of the representational role of QM seems to imply a form of solipsism or idealism. If RC is taken to be a minimal realist commitment, then its rejection may imply the abandonment of physical reality altogether. We shall argue below that this alternative understanding of RC status is mistaken as well. Maudlin's argument. In his defense of the claim that RC is analytic, Maudlin offers the following. Suppose, as the criterion demands, that I can, without in any way disturbing a system, predict with certainty the value of a physical quantity. For example, predict with certainty how the system will react in some experiment. Then, first, there must be some physical fact about the system that determines it will act that way. Second, it means of determining this did not disturb the system. Then, the relevant element of reality obtained even before the determination was made, and indeed obtained independently of the determination being made. Okay, so if you can make a prediction and its result is certain, then you have not interfered with the system. I mean, but what about if your prediction is about your interference? I don't know. Okay. Maudlin's argument supposes one is in a position to predict with certainty the outcome of some measurement on a system without disturbing the system. That is, there is some physical quantity associated with observable A, and one is certain that the outcome of a measurement O sub I will yield a particular value of little a of big A. Probability of OA equals 1. Maudlin's argument centers on two key claims about such a situation. There is some physical fact about the system that determines it will behave so as to yield O sub A. The physical fact in question is independent of the non-disturbing procedure by which we come to know probability O sub A equals 1. The physical fact, the determinant of O sub A, is the element of reality corresponding to the value A of the physical quantity. The big A that appears in our physical quantity big A that appears in RC. One needn't identify the physical fact with the system's possession of the value little a of big A. So as long as there is some physical fact about the system that determines O sub A will occur if one measures big A, it has found the fact corresponding to A, big A that is. On some interpretations, the physical fact in question is the system possessing value little a of big A, but other interpretations will deny this for some observables. For instance, the Bohmian may point to a spatial configuration of particles as the determinant of a measurement concerning an ostensibly non-spatial observable. The intuition here is that without some such prior or independent physical fact, we wouldn't be in a position to be certain of the measurement outcome. Okay. So, yeah, depending on, I'm not entirely certain about all the details in here, but I understand the perspective. If you can predict some outcome, and your prediction methodology does not have any bearing on the outcome, but you can still predict, then it seems like the prediction is following in some sort of, you haven't actually measured in a disturbing way, and so it follows somehow from the theoretical setup that you have to begin with. But okay, so let's see. Objections. Claim 1 is motivated. Alright, so what? Claim 1. There is a physical fact about the system that determines it will behave in a certain way, and the physical fact is independent. Yeah, two key claims. Objections. So we're going to look at the that there is a physical fact of the matter at this point that determines the outcome. Claim 1 is motivated by the certainty of the outcome of O sub A. In standard quantum mechanics, the probability of a measurement outcome is given by the quantum state assigned to the system and the Born rule. Here we suppose that the standard formalism of QM delivers probability of O sub A equals 1, that is certainty with respect to finding the system to be little a. So far so good. But why suppose that this probability claims requirement requires an underlying physical fact that determines O sub A? Yeah, what do you mean by determines? Alright. Indeed, there is a long tradition of denying the inference from certainty to reality. The subjectivist or personalist schools maintain that probability statements correspond to agents' subjective degrees of belief. Thus, probability phi equals 1 means only that one is certain of phi, which need not imply that phi is the case. In the content of quantum mechanics, subjectivism has been explicitly advocated by cubists. For the cubist, when quantum mechanics delivers a probability 1, this indicates that an agent's belief reflected in the quantum state she describes suggests that she should be certain to experience the outcome in question. But, of course, this doesn't imply that there is some physical fact about the system that ensures the outcome. Probability 1 statements are a reflection of an agent's degree of belief, just like any other probability statement. Interesting. Okay. In defense of 1, Maudlin claims that if a system is certain to do something physical, then something is in its physical state entails that it will do it. However, this begs the question against the subjectivist who who takes "it is certain that the system will do phi" to mean some agent is certain that the system will do phi, which needn't imply anything about the physical state of the system. Okay, alright, let's see what the author says Maudlin can reply then. Now, Maudlin may reply that RC's phrase, "we can predict with certainty," implies not just that one can be certain, but that one would be correct in doing so. If this is the case, then perhaps we do need some physical state to provide the basis for one's prediction. But this move is also question-begging, and at any rate not particularly helpful. First, on the classic subjective Bayesian approach which inspired Cubism, there are only coherence constraints, that is, conformity to the probability axiom and Bayesian updating. Thus, it doesn't make sense to speak of a single-case probability as correct or incorrect. Second, even if we grant that one is correct or justified in being certain that phi will occur in the future, or would occur in the measurement we performed, this certainty needn't require a physical determinant to be present in the system now or in the actual world. One could be justifiably certain about a future event in an indeterministic universe, in which case there would be no prior determinant of the event. Suppose, for instance, that there is an oracle who has direct access to a future measurement and the outcome of which the result of a random indeterministic process. One could be justifiably certain to find that O sub A without the presence of a feature of the system now that determines the outcome of this future measurement. Okay, sure. I think this argument is right. There's a little bit of question begging going on in these and number one, if the cubist is going to deny that the existence claim, there is some physical fact, that's a presupposition about how we understand our theories and what they're saying. So if someone's a subjectivist, they wouldn't say there is some physical fact, they'd say there is certainty of something physical. And so wouldn't the existential force would be on the subjective certainty, not the physical fact. So this is a question. The second thing is, if there, I wonder if the author will get to two, but the idea that even if you are to claim there is some physical fact, how would you actually be able to know of its existence in a system if you have not had any interaction with said system? It's like, I can say there's a physical fact about a system a billion light years away. Okay. But it's like I'm making that up, that there is a particular physical fact about it. It's not just laws of nature, there is some specific physical fact about that system. Well, how do you know that? So it's a little bit questionable to have the existential force on it without any sort of access to the system. And so the physical fact in question is independent of the non-disturbed, how we know the probability. I'm not saying how we know the probability is there. I'm saying how do we even if we're not subjectivists, how do we know that there is some physical fact about a system that determines how it will behave? Because even understanding any particular fact would usually involve engaging with it, and that would start shaking our certainty of the physical fact itself, like the physical reality itself. And so once you get to that state, you're not actually so sure about what the physical fact consists of. You might have some like error bars or something, but I'm also worried that the sum here is suspicious. So even if you're not worried about the there is, I'm worried about the sum right here. What exactly does a physical fact amount to? What is the sum? Some sort of physical fact. And so how do you actually set correct bounds for what counts as your physical fact? Because at the bounds you're still going to have like sort of error there, and so I'm not sure you're going to ever get to probability 1 when you have physical facts of some weirds, depending on how you define them. So second sort of a little worry about that, number 1, at least on my side. Okay, objectivism. The objectivist holds that probabilities are genuine features of reality. Even on this understanding, one may wish to resist the move from probability 0 O.I to 1 to 0 O.I being determined to occur. Yeah, this might be close to what I'm saying. First, indeterministic laws may assign a future event a probability of 1. One may wish to deny that the event in question was determined to occur. Second, there are cases in which suggest that probability 0 events are not impossible or determined not to occur. An objectivist persuaded by such cases will deny that probably one events must occur or are determined to occur. Alright, so I guess on this account there is no absolute certainty in either direction. There's no probability 0 and there's no probability 1. You've just got like the limit from any slightly above 0 to slightly below 1. So thanks, Stretch Dad. I don't really know about if I need a manager for what I'm up to right now, but I appreciate it. Thanks for stopping by. Okay. One may wish to deny... Okay, moving on. There are several well-known cases. Consider, for instance, a dart with a perfectly defined tip thrown at a dartboard. On the standard probability calculus, the probability that it hits a particular point is 0, but it is possible that it does so. Or consider a fair coin flipped an infinite number of times. The probability of any given sequence, for example all heads, is 0, but some such sequence must occur. Some cases can be dealt with by allowing for a non-standard probability measure that assigns infinitesimal probabilities to each event in an infinite outcome space, but Williamson argues that this strategy fails in the infinite coin flip case. Granting that such cases exist leads to inconsistency if one assumes that probability phi equals 1 ensures that phi occurs. In particular, this supposition could lead to a situation in which for all phi not the case that phi will occur, and yet there exists some phi such that phi will occur. As a result, some will deny the general principle that probability phi equals 0 and ensures that phi will not occur, and correspondingly that probability phi equals 1 ensures that phi will occur. This applies just as much to the objectivist about probabilities as to the subjectivist. An objectivist account of quantum probability that squares with these general considerations has been developed by Stairs. Stairs advocates minimal objectivism according to which objective quantum probabilities are grounded in facts about the actual world. However, he rejects the inference from a measurement outcome with objective probability 1 to a property of the target system. When Alice makes her probability 1 claim about Bob's qubit, she does not need to infer pre-existing properties nor attribute counterfactuals. On the contrary, if she wants to square her objectivism with causal locality, those are exactly the things she should not do. On Stairs' view, quantum theory provides us with the objective probabilities in virtue of capturing global statistical patterns, not local intrinsic properties. Okay, so this is basically saying there is no objectivity, and therefore there is no objectivity, like no absolute objectivity, and so you're never going to have a probability of some event being 1. This is pretty close to what I was saying, probably done better than how I was saying it. Although it's more a question of interpreting this statement. I'm interpreting it like the semantics of a physical fact. What actually do we understand by a physical fact? These folks, the objectivists, are saying, look, nothing in this world is that certain to be probability 1 or probability 0. So they're focusing over here on this sort of thing. We can't come to know probability of outcomes A is equal 1. Okay, so that's I think a second fair objection that has been made. Alright, but that doesn't really matter because it seems like author thinks Maudlin has a point even if Maudlin didn't make it in the way the author likes. Wither physical reality. Wither. Given the difficulties that beset Maudlin's argument, we contend that RC is not analytically true. As a consequence, views that deny RC, for example cubism, cannot be dismissed as incoherent on this basis. However, RC is a modest representational thread linking quantum mechanics and reality, and hence one may view its denial as abandonment of the physical world. This suggests a revision of Maudlin's analyticity claim. One cannot deny RC without abandoning physical reality altogether. Alright, so they're just dropping the analytic part, but saying you're still losing what you want. You're throwing the baby out with the bathwater when you deny RC. Indeed, this worry may be thought to be understood by a number of no-go results that appear to push quantum epistemicists toward even more subjective positions. Bell's theorem and more recent results, all these folks, are taken by some to require that subjectivism cannot be limited to quantum states, but infects other facets of the epistemicist picture, such as Hamiltonians and measurement results. Thus, one may wonder what is left to form the basis of physical reality. If there are no quantum states, probabilities, or even measurement results in external reality, perhaps nothing remains but the content of an agent's mind. However, even if one adopts a thoroughgoing subjectivism about quantum mechanics, solipsism or idealism need not result. It is perfectly consistent to maintain both that A, there is a physical reality, and B, quantum mechanics doesn't directly represent it. Certain epistemic approaches reject RC as a link between theory and reality, but they allow for a more indirect connection between the two. At the very minimum, they maintain that reality is such that quantum mechanics is a good guide for the agent to find themselves in it. Such a view may be unsatisfying for one who shares Maudelin's realist inclinations, but it is far from incoherent. In fact, Cubism aims to go further than this. For instance, Cubists claim that the Born rule correlates with something that one might want to call real. Such claims of objectivity in Cubism certainly require some unpacking, but they provide a glimmer of a more indirect route to reality. I mean, you're going pretty anti-real there. That's fine, I guess. We conclude that opponents of Cubism and other epistemic approaches to quantum mechanics must do more than merely dismiss these views as incoherent or inconsistent with the existence of physical reality. Okay. That's a nice little paper. Especially in this area, you don't always get short philosophy of science papers. I've done a few philosophy of science papers here, but this one basically takes aim at the RC up here, and then shows that one of the uses of it is it doesn't work. You can't get the defense you want because the analyticity defense of it falls down. Still, it is a minimal claim about how to connect reality to the science, and so it's a nice paper is basically what it comes down to. This like element of reality corresponding to that quantity. I do share the worry that if something is this analytic, that you can just define yourself into saying there exists something with if it has probability 1, then it has an element of reality to it. I fear that I'm not entirely sure what you mean by reality at that point, because it's the old garbage in, garbage out. So if you're putting only analytic stuff in, then how did you get anything non-analytic out? So I'm a little worried about the notion of reality, that if you did accept this, what would the notion of reality actually be? See, this is a slightly coming at this from the other direction. They're saying, well, they were attacking the kind of notion that there's probability 1, there exists something. I'm a little worried about this reality criterion to say what is the notion of the real in scientific realism that relies on this reality criterion. So that is a different worry that I kind of have at the moment, just looking at it. But according to everything else that's going on here, it seems like a nice... I mean, I don't know enough about Cubism either to really understand this sort of epistemic approach, but that's okay. I agreed with the author's analysis that there's something begging the question about this number 1 here, and then the fact that you can deny the that any outcome is probability 1. That's a pretty reasonable position. So that, or at least it seems reasonable, that when you get to reality, nothing is actually certain. So that also is a pretty good argument at that point. I worry about the sum here, which is a slightly different worry. But okay, so that's it for now. This was a nice little paper in the philosophy of science, and I hope everyone stays safe, has a good night, and I'll be back on Tuesday, I think, So thanks for watching, and send me suggestions, questions, or anything else you'd like me to talk about. And have a good night, and stay safe, folks.